Good afternoon, students. I hope you are all well. We are done with exercise 10.1. Okay, now we are going to start with exercise 10.2. And first of all, let me remind you, each and every formula that I am teaching you and each and every part of the theory is quite crucial for you to understand the later part of the chapter as well as to get your basics for the geometry. Okay, so we will start with sum of measure of all the exterior angle of a polygon. That is the name of the topic that we are doing currently, and based on this topic we will be attempting exercise 10.2. okay, and once more, all the theory part is to be done in your class copy, and you have to do questions in your homework copy that I mention in every video. Okay, so we'll start with sum of measure of exterior angles of a polygon. I've already told you, but we will write down it once again. For a polygon, sum of all the exterior angles for a polygon, sum of all the exterior angles is always 360 degree. For a polygon, sum of all the exterior angles is always 360 degree. Okay. Okay. What does it mean? How does it signify? See, suppose we have a pentagon. 1, 2, 3, 4, and not this. This will be the fourth side. Okay, suppose you have a pentagon like this. This pentagon have 4 sides and there are total of 5 exterior angles. So what this property means, that is, if you add angle 1, angle 2, angle 3, angle 4 and angle 5. If you add all of these angles, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5. Okay, for the sake of reference, I have not taken it as a regular pentagon. Okay, it will be quite easy for it to be a regular pentagon and sum of all these angles to be 360 degree. I have taken an irregular pentagon, means none of these 5 angles are equal. None of these 5 angles are equal. But if you measure all of these angles and add all of them, then the final result is always going to be equal to 360 degree. Same applies to any polygon of n number of sides. Same thing apply to a decagon, same thing apply to a triangle, same thing is going to apply for, suppose you have a polygon with 100 sides. It doesn't matter. For each and every polygon, the sum of all the exterior angles, and in the figure you can easily see what are the exterior angles. Okay, these angles marks 1, 2, 3, 4, 5 are the exterior angles. Interior angles will be this one. These green shades. These will be interior angles. What are interior angles? Angles within the polygon. What are the exterior angles? Angles outside the polygon at the vertex of the polygon. What are exterior angles? Exterior angles are angles outside the polygon exterior angles are angles, let me do. Exterior angles are angles outside the polygon at the vertices of polygon okay, two things, outside the polygon, at the vertices of polygon, and most crucial part, and it makes, and it is the linear pair of the interior angle at the same vertex. Okay, keep that in mind. This last part is the most crucial one. Okay, most of the students, even after knowing what is an exterior angle, are still unable to identify how to differentiate between any other angle and exterior angle. Okay, there are lots of angle at a point, and if the student is unable to identify it, then it is a great problem. Okay, so what you need to do is you need to identify. Suppose I name these A, B, C, D, E. I name interior angles as A, B, C, D, E. Okay. So what is happening here is that A angle and one angle are on the same vertex. Angle A and angle 1 are on the same vertex. Okay. Angle 1 is outside the polygon. Angle A is inside the polygon. And lastly, if you add angle 1 and angle A, the sum will be equal to 180 degree because they are forming linear pair. We have already discussed what a linear pair is. Okay, when we discussed question number 9 of the previous exercise, D part, we discussed about the linear pair. And here angle A and angle 1 are both linear pair angles. Their sum is 180 degree. Okay, keep this in mind that what is an exterior angle. Don't get confused with unnecessary things. Okay, a few more things. Note down, write down notes. We have already noted that sum of all the exterior angle is 360 degree. Okay. Next is for a polygon with side n, for a regular polygon with n sides. Okay, why I'm stating regular polygon? So by saying regular polygon, I'm stating that all of its sides are equal. That means all of its interior angles will be equal, and by default, by conclusion, all of its exterior angles will also be equal. Okay, so this thing only apply for a regular polygon. Okay, don't get confused about a regular polygon and other polygons. This is only for regular polygon. For a regular polygon with n sides, the value of each exterior angle will be the value of each exterior angle will be 360 degree upon n. Okay, and although we have already discussed what will be the value of each interior angle, but I will write it down once again. And value of each interior angle will be n minus 2 into 180 degree upon n. Okay, so this will be the formula for each exterior angle of a regular polygon, and this will be the formula for each interior angle of a regular polygon. Okay, I guess this is all that we need to complete next exercise. If there is anything else, I will discuss it with the question. Okay, first of all, we will start with question number 3. Okay, I will leave question number 1 and 2 to you. Okay, let's see if you can do that. If you encounter any problem regarding these questions, please inform me so that I can include that in my next video. So we will start with question number 3. First of all, let me write down the question for you and then I will draw the diagrams. Question number 3 is, find the value of x for each of the following. We have done similar type of question in previous exercise. That was question number 9. And this type of question we are encountering again. Find x in each of the following. Find x in each of the following. We have to determine the value of x for each of the following. So first of all, A part, and I will first of all draw the diagram as it is given in the book. This is one line, then this is another line, and then finally a third line. There are some arrows. This is an arrow, this is an arrow. There is no arrow here, but let me make it. There is an arrow here as well. This is point P. This here is third point Q. You can also check the diagram in your book if you want to. This is x degree. This angle is 130 degree. And this angle is 95 degree. Okay. Now, students, by seeing the figure, I can see that all three angles are exterior angle of this triangle PQR. Okay. So let me share how do I identify that these are correct pair of exterior angles. Okay. How do I identify that these are correct pair of exterior angles? That is very important to understand. Okay. What I see is all the exterior angles. Okay, see, let us take side RQ. Okay, it is below RQ. This exterior angle is below RQ. And let me rotate the diagram for you if I can. I will see if I can. First of all, let us shift question somewhere else. Okay. And let me shift this as well. Why not delete it? Unnecessary thing. And let me take this diagram and rotate it. Okay, I've rotated this diagram. Okay, so that you can identify the position of each and every angle. See, now for line QP, this is line QP, the angle X, the exterior angle is below the line. Okay. And okay, let us rotate it once again. Again, for line RP, as you can see in the diagram, for line RP, the exterior angle again is below the line. And finally, for line RQ, once again the exterior angle is below the line. Okay, so what is happening here is, however I rotate the diagram, the position of exterior angle is always below the diagram. Okay, it could have been always at the right side of the diagram, it could have been always at the left side of the diagram, or it could have been always at the top of the diagram. Okay, depending upon the type of exterior angles, there are at least two exterior angles. Sorry, exactly two exterior angles for any polygon. Okay, I'm not trying to confuse you at this point, so I will not elaborate much on it. But by rotating your book, okay, you have a diagram in your book. By rotating your book, you can clearly understand which one is the exterior angle. Now, how to solve this one? We will simply state that since we know that We are simply stating for this triangle, since we know that sum of all the exterior angle of a polygon sum of all the exterior angles of a polygon is 360 degree. That means 90 degree plus 130 degree plus x should all be equal to 360 degree. How do I get it? 90 degree is exterior angle at point P. Okay. 130 degree is exterior angle at point R, and x is exterior angle at point Q. All of this should be equal to 360 degree, and that means x should be equal to 360 degree minus 90 plus 130 is 220 degree. That will be 140 degree. So the value of x is going to be 140 degree. I guess it is quite simple. Let us see for B part. Okay, once again let me draw the diagram for you, then we will discuss how to do this. B part is, there is a line at the base AB, then from point B there is a perpendicular BC, then from point C there is CD, and from D we have DE, and from E finally we have EA. And let us see what the angles will be. First of all, arrow, 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 arrow. These arrow indicate that all of these are rays, and this is angle A, this is angle B here, here is angle C, angle D, and point E, and there are angles associated with these. Angle A is 65 degree. B, there is no angle mentioned, but this sort of thing we already know, it is a 90 degree angle. That means its adjacent angle should also be equal to 90 degree. This angle here is 40 degree. This angle at external angle at point E is 80 degree, and external angle at point E is 60. So once again let me do the same thing. We have external angle, first external angle below the line AB. Let us see if all of the exterior angle that we are given are below the lines. So this angle is also below the line, good. This angle is also below the line, once again good. Okay, you can understand it, right? It is quite visible that 40 degree is below the line. Then once again 80 degree, you get 80 degree, this angle is also below the line ED, and then I rotate it once again, then angle X is also below the line, and back to the original shape. Okay, so this time also we need to do what? We need to do the same type of procedure. We will say that since sum of all the exterior angles is 360 degree, since for a polygon okay, that means sum of all these angles should be equal to 360 degree. So we will start with point A, 65 degree, plus point B we have 90 degree, plus point C we have 40 degree, at point D we have 80 degree, and at point E we have X, and all of these should add up to make 360 degree. So 65 plus 40, 180, sorry, 105, 90 plus 105 plus 90, 195, 195 plus 80, 275. Okay, and please check, don't mind if my calculation is wrong. Okay, please correct it if I am wrong. This will be 360 degree minus 275 degree. Okay, so this will be 5 and 15 minus 7, guess it is 8, 85 degree. Let me check the answer. It is exercise 10.2. The value of x should be 85 degree. Exercise 10.2, third part B, 85 degree. Yes, it is the correct answer. So that means my calculation should have been correct. Okay. And one thing, students, for exercise 10.2, you have to complete all the exercise in your homework copy. Okay. What we are discussing can be done in your class copy if you want to, but all of this is to be done again back in your homework copy as well. Okay. Next is question number 4. Question number 4 and 5, I will do one part of each, and remaining one part should be done by you. Question number 4 is quite easy. We can easily do it on the basis of the formula that I have discussed with you. Find the measure of an interior angle of an interior angle of a regular. I'm taking A part for both of these. This is question number 4. I will take A part for question number 5 as well. A part is octagon. So first of all, we should know that for an octagon, how many number of sides does an octagon have? It has 8 sides. Okay, an octagon has 8 sides. Okay, so we have to find the measure of interior angle. So interior angle, this is regular octagon. So here value of n is 8. Interior angle for any polygon is given by n minus 2 into 180 degree upon n. So this time this will be n minus 2, 8 minus 2 into 180 degree upon 8. So this will be 6 into 180 degree upon 8. We have to simplify it. 4, 0, 3 8s are 24, 3 1s are 3, 5, 540 upon 4, and when simplified, 4 1s are 4, 4 3s are 12, 4 5s are 20, 135 degree. So every interior angle for this octagon will be 135 degree. Okay. In the same manner, you can do for hexagon. Hexagon has how many sides? Okay, I have already told you, you should know about this. I'm not going to repeat that. Question number 5. Question number 5 is, find the measure of exterior angle for a regular polygon. This time we have to determine exterior angle for a regular polygon. So once again, A, 15 sides. Students, above decagon, although the polygons are named, but there are so many names, so we don't need to focus on those. Okay. And please don't ask what does a polygon with side 15 means. What is its name? If you want to know, Google it. So for this, for n is equals to 15. There are 15 sides, so n is 15. Value measure of exterior angle. So exterior angle for this polygon is 360 degree upon 15 degree. Let me write down the formula first of all. The formula for exterior angle was 360 degree upon n. So this time it is 360 degree upon 15 degree. We will simplify it simply. 3 5s are 15, 1, 20, 2, 4. So it is 24 degree. Okay. So we will continue with this exercise in our next lecture. That's all for today. Once again, all of the question of this exercise are to be done in your homework copy. I will discuss question number 6, 7 and 8 in the next video. Thank you for your time. Have a nice day.